Hello. We would like to reference Wikipedia, hydraulic ram. In 1772, John Whitehurst of Cheshire, United Kingdom, invented a manually controlled precursor of the hydraulic ram, called the pulsation engine, and installed the first one at Alton, Cheshire, to raise water to a height of 4.9 meters, 16 feet. In 1783, he installed another in Ireland. He did not patent it, and details are obscure, but it is known to have had an air vessel. The first self-acting ram pump was invented by the Frenchman Joseph Michel Montgolfier, best known as a co-inventor of the hot air balloon, in 1796 for raising water in his paper mill at Voiron. His friend Matthew Bilton took out a British patent on his behalf in 1797. The sons of Montgolfier obtained a British patent for an improved version in 1816, and this was acquired, together with Whitehurst's design, in 1820 by Josiah Easton, a Somerset-born engineer who had just moved to London. Easton's firm, inherited by his son James, 1796 to 1871, grew during the 19th century to become one of the more important engineering manufacturers in the United Kingdom, with a large works at Erith, Kent. They specialized in water supply and sewerage systems worldwide, as well as land drainage projects. Easton's had a good business supplying rams for water supply purposes to large country houses, farms, and village communities. Some of their installations still survived as of 2004. The firm closed in 1909, but the ram business was continued by James R. Easton. In 1929, it was acquired by Green and Carter of Winchester, Hampshire, who were engaged in the manufacturing and installation of the well-known Vulcan and Vach rams. The first U.S. patent was issued to J. Cern and S.S. Hallett in 1809. U.S. interest in hydraulic rams picked up around 1840, as further patents were issued and domestic companies started offering rams for sale. Toward the end of the 19th century, interest waned as electricity and electric pumps became widely available. By the end of the 20th century, interest in hydraulic rams has revived, due to the needs of sustainable technology in developing countries, and energy conservation in developed ones. A good example is Aid Foundation International in the Philippines, who won an Ashton Award for their work developing ram pumps that could be easily maintained for use in remote villages. The hydraulic ram principle has been used in some proposals for exploiting wave power, one of which was discussed as long ago as 1931 by Hans Günther in his book In 100 Jahren. Some later ram designs in the UK called compound rams were designed to pump treated water using an untreated drive water source, which overcomes some of the problems of having drinking water sourced from an open stream. A hydraulic ram has only two moving parts, a spring or weight-loaded waste valve sometimes known as the clack valve and a delivery check valve, making it cheap to build, easy to maintain, and very reliable. In addition, there is a drive pipe supplying water from an elevated source, and a delivery pipe, taking a portion of the water that comes through the drive pipe to an elevation higher than the source. Basic components of a hydraulic ram: inlet, drive pipe 1. Free flow, at waste valve 2. Outlet, delivery pipe 3. Waste valve 4. Delivery check valve 5. Pressure vessel 6. Initially, the waste valve, 4, is open, and the delivery valve, 5, is closed. The water in the drive pipe, 1, starts to flow under the force of gravity and picks up speed and kinetic energy until the increasing drag force closes the waste valve. The momentum of the water flow in the supplely pipe against the now closed waste valve causes a water hammer that raises the pressure in the pump, opens the delivery valve, 5, and forces some water to flow into the delivery pipe, 3. Because this water is being forced uphill through the delivery pipe farther than it is falling downhill from the source, the flow slows. When the flow reverses, the delivery check valve closes. Meanwhile, the water hammer from the closing of the waste valve also produces a pressure pulse which propagates back up the supplely pipe to the source, where it converts to a suction pulse that propagates back down the pipe. This suction pulse, with the weight or spring on the valve, pulls the waste valve back open and allows the process to begin again. A pressure vessel, 6, containing air cushions the hydraulic pressure shock when the waste valve closes, and it also improves the pumping efficiency by allowing a more constant flow through the delivery pipe. Although, in theory, the pump could work without it, the efficiency would drop drastically and the pump would be subject to extraordinary stresses that could shorten its life considerably. One problem is that the pressurized air will gradually dissolve into the water until none remains. One solution to this problem is to have the air separated from the water by an elastic diaphragm, similar to an expansion tank. However, this solution can be problematic in developing countries where replacements are difficult to procure. Another solution is to have a mechanism such as a snifting valve that automatically inserts a small bubble of air when the suction pulse mentioned above reaches the pump. 9. Another solution is to insert an inner tube of a car or bicycle tire into the pressure vessel with some air in it and the valve closed. This tube is in effect the same as the diaphragm, but it is implemented with more widely available materials. The air in the tube cushions the shock of the water the same as the air in other configurations does. Our point of showing detailed information about the hydraulic ran pump. The operation of this pump shows the same action that we have shown in the VTA's action. It works the same way. One valve, or gate is open and the other is closed. It is stress that can be tapped, exactly as Tom Bearden said, and we quote,
"Anything that is stressed, you can tap energy out from. God Almighty forever, if you can get it to do this process, and get over gain 1, which you can do under the oscillation condition. Now I ain't going to tell you how to do that, that's the inventors, that I work with, their secret, but that's the principle and it works on the bench. You can tap stress itself."
This reference from Radionics Action at a Distance available from the Tom Bearden website. We hope to have more information soon. Thank you for supporting our projects.